Alrighty, so let us take a stab at describing, as I like to say, describe the heck out of this graph. And so I didn't write our graph investigation questions because we've kind of already gone through them once, but let's start off with the shape. So let's talk about the shape of this graph. So one thing we could definitely point out is it is not linear, right? There's not a straight line that goes through all these points because, well, if I try to maybe do the first two, I'm missing all the other ones. So it is for sure non-linear. We could say it's also curved. The reason I say non-linear and curved because you could have non-linear but not curved because you could have a straight zigzag, something crazy like this, where they're all just straight pieces. And so it is curved, but actually take a second, kind of turn your head. My camera's still funky, but if you turn your head clockwise and look at this graph, 90 degrees, it actually should look quite familiar. And if you think it looks like half of a parabola, you'd be actually exactly right. It actually is exactly half of a parabola. And so this is indeed a half parabola. On its side. And if you want to be even more specific, that I spelled out parabola. It's half a parabola that is opening not up or down now, but to the left in this case. So it's a half parabola on its side, opening to the left, and more specifically, it'd be the top half. But we don't have to be that specific. That's okay. All right. In this case, if it was a full parabola, it would have symmetry, right? Because you could fold that piece over essentially this piece. In this case, like the line of symmetry would be horizontal. Oop. But in this case, because this bottom half is not actually there, there is no symmetry. So I'm going to say over here, I like to put the symmetry question underneath the shape question because they're so similar. There is no symmetry here. Okay. So in this video, you'll notice that I am kind of answering them with like bullet point style, which is okay. I just want us to be, in the previous video, I used full sentences just to make it really clear about what we're saying. Okay. Next question we want to talk about, and there's no particular order here, but we could say, is it increasing or decreasing? And so let's see, is it increasing or decreasing? Well, let's see, increasing or decreasing. We talked about this in the previous video about when we were graphing it, how the numbers that you're plugging in, let's just double check what our equation is. X plus 1 take away 4. As you plug in bigger x's, as in going from left to right, the x values you're plugging in are getting bigger. And so if the numbers you're taking the square root of are bigger, then the resulting square root is bigger, right? So 4 is smaller than 100, let's think of it the other way. 100 is bigger than 4, and also the square root of 100, which is 10, is bigger than the square root of 4, which is 2. And so I think it's pretty clear that this graph is increasing as we go left to right. Again, increasing. And it's only ever increasing. It's never decreasing. It's never going down, and it never stays the same. So it's always increasing. It's always increasing. While we're at it, talking about increasing, decreasing, we can also talk about the growth rate or the rate of increasing / decreasing. Growth rate, is it constant or does it change? And so we can think about this. Notice here, I can draw a little, what you might have heard this term called slope triangles before. If I'm going to draw them in green here. Notice here, how far up do I go between points? So the change in the y value, this is plus 1 in the y. And sometimes some people might say triangle y. This stands for delta y. I'm getting maybe a little ahead of ourselves. Delta, like that's how you say that triangle is delta, or change in y. Change in y. And how many steps in the x direction did it take to increase that y by 1? Well, we went from -1 to 0, so change in x, or delta x, is equal to 1 as well, plus 1. Okay, but let's take a look at the next one. We'll draw this one in blue. If I look at the next bit, the change from the next points, notice here, my change in y right here, oopsies, my change in y is plus 1 again. But what's my change in x? How many steps did it take in the x direction horizontally? How long did it take to get that change in y of just 1? Notice here we went from 0 to 3, so it took 3 more. And the next one you can see here, and this will be the last one that I do, my change in y, once again, I just went from 0 to up to 1. To get just one change in y, how many steps in the x direction did I have to take? Well, I had to go from 3 to 8, which is 5. And so you can notice, as we go left to right, what's happening to the growth rate? Well, at first, I only need to take one step in the x to go up 1 y. The next one, to make even just that tiny change of plus 1, how far did I have to go horizontally? I had to take 3 steps. So I'm going up slower because it's taking me longer to go up by that same amount. And likewise, if we keep going, the next one, that final green one, to go up 1, I had to go over 5. And you can see that that's getting stretched out even more over here, where to go up 1, you need to go, how far in the x direction? I think 7 right there. And so that's where a way that we can see our growth rate. Our growth rate, it starts fast, but it actually slows down. The growth rate, it slows down as you go left to right, or as x increases, i.e. as we go left to right. If there's a question about this, please ask, because I don't know if I said it like super duper clear, but this is definitely something we want to get used to, because a lot of this class and so far we've talked about it a lot, talked about growth rates and how we can observe them. Alright, so that's the growth rate. Another thing we want to point out are there any special points on this graph? So I'll start down here, I guess. Still in blue. Let's make this a little bigger. Special points. So if we remember from our parabola video, we always want to talk about intercepts if possible. So where is our x-intercept and where is our y-intercept, if they even exist, because the graph might not have them. Remember, we can see our x-intercept that's where the graph crosses the x-axis. So I should have labeled our axes here, x and y. But we can see here, the x-axis, that comes up right here always has a y coordinate of 0. Because if you're on the x-axis, you didn't go up or down at all, so the y coordinate of that point should be 0. That's how you can find the x-intercept. And so our x-intercept is at 3, 0. And it looks like that's the only one because the graph doesn't go up and then down. And we can see the y-intercept. The y-intercept is at, let's see, that would be, if you're on the y-axis, you didn't go left or right at all, and so your x-coordinate should be 0. So that's going to be that point right there, 0, -1. 0, -1. And it looks like this graph has only one y-intercept and one x-intercept. We could also point out here that -1, -2 kind of is special, because if you take a look at this point, it's kind of where the graph actually starts, right? The parabola doesn't quite have a starting point because it goes off forever in both directions. It just keeps going down or up, depending on the parabola. But this one actually does. And if we think about it as a half parabola on its side, that would be the vertex, actually. And so -1, -2, we call it the farthest, the starting point of the graph. point of the graph. I suppose you could call it the vertex if we indeed call this a half parabola. So I would call it the vertex in quotes of the half parabola. How about that? Maybe we could agree on that. All right. Almost there. We did talk about, is there a minimum or maximum, or sorry, a highest or lowest point, we'll say. Sorry, let me box these things off so we know where the questions start and end. Okay, two more questions. Highest or lowest point. And so we can actually see the lowest point, and this is where we kind of talk about how the graph, as we go left to right, is only going up. That lowest point, the lowest point is at that kind of starting point, that vertex. The lowest point is at -1, -2. And since there isn't, again, we're plugging in bigger and bigger numbers. If you plug in, say, 100 million, when you plug this in, you're going to get a pretty big square root, right? Now, 100 million and 1 is going to be not that different, but it is still bigger than the square root of 100 million. And so even though it goes up very slowly towards the end, although there is no end, as you go really far in the x direction, the growth rate is minuscule, but it is still going up. And so there actually is no highest point. It's going to, even if you think you're at the top, if you just take one more step that way, you'll be a little bit higher, and then a little bit higher, and a little bit higher. And so there is no highest point. Whew, almost there. The last part is what x and y values are hit or used. And so let's think about this. You can kind of see this on the graph again, where we scan kind of left to right. Where does the graph start horizontally? Well, the very first x value comes up at -1 right here. In what color should I use? In pink. The graph starts kind of right there. If I go over here at, say, -3, there's nothing there. There is no graph there. And so I start off at -1. And if I keep going, check here, oh, hey, the graph is there. Hey, the graph is here. And I could keep going left to right, and there's always going to be a graph there, or a piece of the graph there. And so what x values, it uses -1, like that's where it starts, and greater, -1 and up, I'll call it, that's fine. And then the y values are, well, let's see, I'll do the same thing as I did with the pink, but horizontally now. It starts off at nothing, 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 nothing until it gets to -2. And it's going to keep going up, 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 up. And yeah, it's going to take, like, when I get to a y value of 10,000, it's going to take a really long time, a really big x value to get there, but it will eventually get there. And so the y values, again, this is referencing this point basically, where no matter how high you go, you will eventually get there. Those y values are from -2 and up. And so this is a super description of this graph here. So hopefully after this video and the previous parabola video, you could take any graph and describe the heck out of it. Alrighty, so thanks for watching. Hopefully now you can try some practice problems, and I'll see you soon.